Hello student, good morning. I am Dr. K.Sinha, Professor of Chemistry. Today I am going to start new chapter, that is thermodynamics, chemical thermodynamics. It is also called energetics and chemical thermodynamics. Now I am going to review of fundamentals of this chapter. Point by point, all important points of this chapter I will discuss. Actually, I am reviewing the entire chapter, thermodynamics, chemical thermodynamics. It is also studied in physics. Okay. But here we will focus chemical thermodynamics, energetics and chemical thermodynamics. Point by point I will discuss. What is actually energetics and what is the chemical thermodynamics, thermochemistry? I will discuss first. What is actually energetic, chemical energetics? Actually, there are three terms you have to understand. First term is chemical energetics. Second term is thermochemistry. Fourth term is thermodynamics. You have to understand the differences among these three terms. One by one you understand. The branch of science which deals with the energy change during chemical reaction is called chemical energetics. The branch of science which deals with energy change. Just this you have to understand. Energy change. The branch of science which deals with energy change during chemical reaction is called chemical energetics. Now, what is thermochemistry? The branch dealing with heat change. There it was energy change. Here heat change. The branch dealing with heat change is called thermochemistry. You know that energy is of the various form. Heat is also energy. Light is also energy. Sound is also energy. Many for light, light also I told you energy only. Light, heat, sound. Then energy means energy has various form. Then here in chemistry we are focusing on heat. One form only, heat. Correct? The branch dealing with heat change, not only heat change, that is important. Heat change is called thermochemistry. And the branch of science which deals with energy change during chemical reaction is called chemical energetic, and the branch dealing with heat change is called thermochemistry. Now come to the third point, thermodynamics. The branch of science dealing with a quantitative relationship between different forms of energy is known as thermodynamics. Different form of energy is, again I told you, it has many forms. Then different form of energy means what? Enthalpy, entropy, correct? Intrinsic energy, kinetic energy, potential energy, all are energy only, correct? Then these also you have to consider as all are energy. Then here you have to change, you have to consider, you have to understand quantitative relationship, not qualitative. Quantitative means how much, that is called quantitative. Then quantitative relationship between different forms of energy is known as thermodynamics. The branch of science dealing with the quantitative relationships. Quantitative, this is important point. Quantitative relationships between different forms of energy is known as thermodynamics. Correct? Now again further other important point I am telling you. The reaction or also you can tell processes. Reaction is also known as processes. The reaction or processes which are accompanied by evolution of heat. The reactions which are accompanied by evolution of heat are known as exothermic reactions, correct? And those which are accompanied by absorption of heat are called endothermic reactions or processes. Okay, the reactions or processes which are accompanied by evolution of heat, liberation of heat, are known as exothermic reactions or exothermic processes, and those which are accompanied by absorptions of heat are called endothermic reactions or processes. Next point I am telling you about system and surroundings. The part of the universe chosen for thermodynamic studies is called a system. The part of the universe chosen for thermodynamic studies is called a system, and the remaining parts of the universe is called surroundings. Means what you are considering. As for example, you are considering only blackboard in classroom. Then blackboard is a system. If you are considering only beaker is a system. Correct? If you are considering only any one instrument, that is the system. If you are considering only computer, that is the system. And rest things are called surroundings, remaining. Then here a system, or you can tell the part of the universe chosen for thermodynamics studies is called a system, and the remaining part of the universe is called surroundings. A system which can exchange both matters and energy. Now here you should understand only in the beginning. You can exchange only two things, either matter or energy. Energy you can't see. As for example, warm water. If you have warmed, suppose 50 degrees centigrade, after some times you will touch the beaker, then you will feel now it will become cold. Then what happened? The heat went to the surroundings. Only heat went, water may be the quantity may be the same. You can't see. When energy is going, you can't observe. Okay, but now if boiling water, if you will see, then you can think, oh, water vapor is also going, heat is also going. Then here, water vapor is the matter, vapor, any vapor, and heat is also going. Then heat means here energy. Then both is going outside. It is going to the atmosphere, means surrounding. Then keeping these two things, matter and energy, now you understand. A system which can exchange both matter and energy with surroundings is called open system. Open, it is open for both. Only you can't give the these things, matter and energy. It can take from surroundings also. Reverse is also possible. Okay. When it is hot, that time it is giving. But now you think that if you can say, if temperature is very low, means cold water you have kept in a beaker, and outside temperature is suppose 35 degree, and cold water, its temperature may be 10 degree or 5 degree. Then what will happen? After some times, now beaker temperature, beaker water will also become the same temperature like outside. Then now it has taken energy or heat from outside. Then it is from both sides it is possible. It can release also, it can give also, it can take also, means exchange is going on. Then exchange will be for both heat and matter, means energy and matter, both can exchange. It can take, matter also can be taken from the outside. Then here open word means matter and heat both can be exchanged. Then a system which can exchange both matter and energy with the surrounding is called open system. And a system which can only exchange energy but not matter with the surrounding is called a closed system. Now restriction is there. It can when only energy is going to be exchanged, not the matter, with surrounding, then it is called closed system. A system by which can only exchange energy but not matter with the surroundings is called a closed system. Now one more system is there. A system which can neither exchange matter nor energy with the surrounding is called an isolated system. Correct? Third system is isolated. It has no link with outside. No exchange, nothing. Separate. Isolated. That's why name has been given isolated system. Then a system which can neither exchange matter nor energy with surroundings is called an isolated system. Now next point I am going to discuss, that is the state function. A state function. A physical quantity. What is a state function? A physical quantity is a state function if its value depends only upon the state of the system. Here a state of the system means initial state, final state. Suppose you have taken one rod or anything you have taken, Then one side, suppose it was cold, other side you have heated. Then in the beginning it was cold, now it became hot. Then initially it was cold, now it became hot. Then that is the initial first state was cold, correct? In the beginning, that is the initial state, and finally it became warm. That is actually other state, final state, that is called. Or any change, suppose you can say pressure was, high pressure was there. Now just suppose pressure is reduced. In the beginning it was the 10 atmospheric pressure, now it became 2 atmospheric pressure. Then now initially it was 10, now it became 2 atmospheric pressure finally. Like that way, volume was more in the beginning, suppose 10 liter, now it became 3 liter. Then in that sense you understand a state, correct? Initial state, final state. Then a physical quantity means here you can understand just like a mass, okay? They have weight, some weight, like that way you can understand. That is actually quantity. A physical quantity is a state function. Physical quantity, you remember, a physical quantity is a state function if its value depends only upon the state of the system. If its value depends only on the state of the system, that quantity is called a state function. Again you listen, a physical quantity is a state function if its value depends only upon initial state or final state of the system, or in a general way, a state of the system. A physical quantity is a state function if its value depends only upon the state of the system. Next point I am telling you, these are very, very important. Actually, I am reviewing the chapters, and here you should tell, I told you system and surroundings. Then you can consider anything in the system. Anything you can consider as a system. Even in the body also. In body so many parts are there inside. There also atoms are there. Entire body is made from atoms. Correct? And from the atoms molecule is formed. And when many molecules will attached, then a small organ will be formed. Correct? This you remember, that our body is made from the atoms. In our body, atoms are present, molecules are present. When molecules are in large quantity, cluster of molecules, then very small organ is formed. Very organ. And when so you can say, if bigger organ is there, from the small organ, bigger organs are formed. Correct? You know that cell, tissues, and all different type of chemicals are also present in body. In our body, full reactions are there. Many reactions are there. Correct? Many reactions are there. Chemical reaction, physical reaction, all type of reactions are going on. Correct? In body, inside the body, many reactions are going on. Hence, whatever chemistry is outside, out of body, that is the general chemistry. But inside the body, that chemistry is known as biochemistry. Only difference is the term of bio. All things are same. Hence, it will apply inside the body also. All things will apply. Okay. What is in general chemistry? That is inside. Only practically it will be different. Practically, you can't see inside all the things, and practical is different. Correct? But theoretically, all are same. Then now, you can consider for the entire body also. Body part, any part of the body that you consider as a system. And remaining parts of the body, that is a surrounding. neighboring things. Surrounding means neighboring also, you can tell. And now I am going to discuss other important properties. You should understand carefully. Properties such as mass, volume, energy, heat capacity, enthalpy, entropy, free energy, etc., which depend upon the amount of the substance, are called extensive properties. Extensive properties, whereas properties like temperature, pressure, refractive index, density, surface tension, melting point, boiling point, etc., which depend on the nature of the substance, are called intensive properties. Again, I am repeating extensive and intensive properties. Properties such as mass, volume, energy, heat capacity, enthalpy, entropy, free energy, etc., which depend upon the amount of the substance, quantity of the substance, are called extensive properties. Correct? Mass means maybe 1 kg, 2 kg, 30 gram, 20 gram, 5 gram, 2 gram, 1 gram. Then mass is considered. Mass actually is related to quantity, amount of the substance. Correct? What is the mass? How will you judge? Whether it is 2 gram, 1 gram, 500 milligram, 5 kg, 10 kg, 2 kg, how much you will decide? That depends upon the quantity. How much quantity is there? Accordingly its mass will be there. Its mass depends upon quantity. If quantity is less, mass will be less. If quantity is more, mass will be more. Like that way, volume also depends upon quantity. Quantity, if small things are there, its volume will be less. If small molecules are there, then volume will be less. Means it will cover very small space. Correct? And if you can say big molecules are there, that volume will be more. It will cover more space. Like that way, energy, if a small wood will burn, it will release you less energy. If a big wood will burn, it will release more energy. Hence, that also depends upon quantity. Come to the heat capacity. Heat capacity, now just by example only you can understand. Heat capacity, what is heat capacity? First you have to understand. Heat capacity is the heat required to raise the temperature by 1 degree centigrade. 1 degree centigrade. To increase the temperature, suppose anything was there, that was its temperature was 14 degree. Now you want to make it 15 degree. Then how much temperature heat is required? How much heat is required to raise that temperature by 1 degree? Means 14 became 15, 16 became 17, like that way. That heat actually is called a specific heat, but quantity you have to restrict. Quantity, correct? As for example, for 1 gram of, suppose you have taken 1 gram, you have taken copper, 1 gram you have taken iron, 1 gram you have taken tin, correct? And you want to raise the temperature by 1 degree, all are 1 degree, 1 gram only. Copper you have taken 1 gram, iron you have taken 1 gram, tin you have taken 1 gram, aluminum you have taken 1 gram, separate. If you want to if you want to increase the temperature, and suppose all are at 14 degree, all are at 14 degree. Now you want to make it 1 degree extra, 15 degree. Then how much heat is required? Then you can measure it. Then you will find that now temperature required to raise the 1 degree for all these materials are different. Temperature raised only 1 degree, but heat required, all four required a different quantity of heat. Then that heat is called a specific heat for that metal, for that particular metal. Then for copper different, for the iron different, for the tin different, for aluminum different. Correct? Then that is called a specific heat. Then a specific heat also you can say depends upon the quantity. Okay, quantity. Then now just I told you, now this is for, you consider only for 1 degree, 1 gram. If 2 gram, then that will differ. 3 gram, that will differ. But for similarity, for 1 gram only you have considered, that is a differential. For differential 1 gram only you have to consider, or for the gas 1 mole you have to consider. Then whatever be a specific heat depends upon quantity. Okay, like that way. Now entropy I will tell you. Okay, what is the entropy? It will take more time to tell. Then entropy and free energy I will discuss all. That depends upon quantity. All these points depends upon quantity: mass, volume, energy, heat capacity, enthalpy, entropy, free energy. All depends upon quantity or amount of the substance. It depends upon the amount of the substance. And these are the example of extensive properties. Just other properties intensive, that depends upon what? These depends upon nature of the substance, not on quantity. Not on quantity. It depends upon nature of the substance. Okay, extensive properties I told you, whereas properties like temperature, pressure, refractive index, density, surface tension, melting point, boiling point, etc. These depends on the nature of the substance, are called intensive properties. Correct? Just now I given example that all different metal for 1 gram that is required these things more different quantity, different heat they required. Correct? Then this temperature only 1 degree raised, 1 degree, but now to raise the 1 degree they require different type of heat. This is different quantity of heat. Then actually this temperature depends upon the nature of the material. Okay, depends upon the nature of the substance. Then this I told you about the temperature. Pressure also depends upon nature of the substance. Pressure. If suppose you have iron, suppose a similar piece of iron, wood, similar length and breadth and height, wood and iron, same dimension, length, breadth, height. Who will create more pressure? You can think, obviously, iron. Aluminum is also there, it will differ. Then that also depends upon the nature. Then this pressure also told, this is the these things intensive properties, because it depends upon the nature. refractive index also, if light will come, refractive index is related to light, then you know that some light will be absorbed by the matter. All will not return. Reflection will not take place for all. Whatever light, incident light is there, little amount will be absorbed and rest will be reflected. Then how much it will absorb, that depends upon the nature of material. Glass may be different, water may be different, correct? Wood may be different. Many materials are there. Then this is also refractive index also depends upon the nature. Density also, all liquids are not having the same density. Water has different density, oil has different densities, all liquids have different densities. Mercury 13.7, that is a density mass by volume, means 1 ml of water, its densities will be only 1 gram roughly at normal temperature. But if you will take 1 gram, 1 ml water, its density is 1 gram, mass by volume, 1 gram per ml. But for mercury 13.7, 1 ml mercury and 1 ml water, then 1 ml means water means roughly 1 gram, but mercury 1 ml 37.7 gram. See, if 10 kg iron and 1 liter, you can tell 1 liter water roughly 1 kg, but 1 liter mercury is liquid, how much weight will be there? 13.7 times more, means roughly 13.7 kg. Water is 1 kg, that is 13.7 kg. Then this also depends upon, that is the nature of the substance. Then surface tension is also depends upon nature of the substance. Different type of liquids are there. Then density, surface tension, melting point, boiling point, everything has different. If liquid is there, then boiling point. If solid is there, then melting point. Then all solids have different melting point. All liquids have different boiling point. Then these also depends upon the nature of the substance. Then now I think you have understood what is the intensive properties. Then these what I discussed, temperature, pressure, refractive index, density, surface tension, melting point, boiling point, all are examples of intensive properties, and these properties depend on the nature of the substance. Now next important terms I am going to discuss, that is the reversible and irreversible process. A process which is carried out infinitesimally slowly. Listen carefully. A process which is carried out infinitesimally slowly, very slowly, is called reversible process. Very slowly I am talking about. A process, a reaction or a process which is carried out infinitesimally slowly is called a reversible reaction. At every stage reaction is going on, suppose reaction is going on, at every stage the system remains in equilibrium. At every stage of the reaction, if you divide in suppose 10 parts, then every stage reaction will be in equilibrium, infinitesimally small I am talking about. Always can say it will be in equilibrium. That's why it will come reversible. Okay. Then a process which is carried out infinitesimally slowly is called a reversible process. At every stage, the system remains in equilibrium. By reversing that condition, the process can be reversed. If a process is carried out rapidly, now you can see the differences. If the process is carried out rapidly, it can't be reversed. It is called irreversible process. One direction only. It can't come back. If a process is carried out rapidly, then it can't be reversed. It is called irreversible process. This is the difference. In reversible, you are considering that is a very slow, infinitely slowly. But here it is in case of irreversible, it is rapidly. Now, actually one example I want to give you. All natural process, all are irreversible. If water is coming from top to bottom, water is coming by own. You are not doing anything, only in one direction. It is not going upside simply by own. Correct? Then like that way you can understand. This is the one example I have told you for irreversible. Many times fast reactions, all fast reactions are irreversible. It will not come back. Now, next point I am telling you types of process. Different type of a process, that is called types of processes, in which some properties is kept constant. Okay. Generally temperature, pressure, concentration. These are the properties. Temperature, pressure, volume and concentration. Okay, generally it is considered as properties. Okay. Then in all these types, any one will be kept constant. Then properties, any one property will be kept constant. There are actually 4 types of process in thermodynamics. 4. What are that 4? Isothermal. Second, isobaric. Third, isochoric. Fourth, adiabatic. 4th process are there. You must know, because without that you can't understand anything of the thermodynamics. You can't understand. Wastage of time. Hence, now slowly I am going in depth. Then now, what is isothermal process? Then its condition is temperature must be constant. Reaction you can tell, or process you can tell. Here, temperature will be kept constant. T is equal to constant. Then here, delta T, change, here always in thermodynamics, delta, change of the 2 states, initial state and final state, that you are considering. Difference you are interested only in difference, not in a you can say absolute value has no importance here. Only what is important? Difference. Then isothermal process. What is this process? In this process, delta T will be 0. Delta T, change in energy, change in temperature. In any reaction, in any process, if change in temperature is 0, means no change in temperature, temperature is constant, then that process is called isothermal process. Similarly, when pressure is kept constant, means delta P is equal to 0, no change in pressure, any process or reaction where pressure is constant during the reaction or during the process, delta P is equal to 0, no change in pressure, that is called isobaric process. And when volume is kept constant, delta V is equal to 0, delta V is equal to 0, means V is constant, V is equal to constant, then that process is called isochoric process. Isochoric. Iso means same. And one more process is there, adiabatic process. What is this? Then in this process, no heat enters or leaves the system. No heat enters or leaves the system. If during the reaction or process, suppose heat is evolved, then it will not go outside. It will be only in the system. And if it decreases, then it will not take from the outside. It will not take from the outside. Means when no heat enters or leaves the system, that is a Q, a small q is equal to 0. Q means heat. Q means heat. Then Q is equal to 0. Then that process is called adiabatic. Adiabatic. Adiabatic process is that process in which no heat enters or leaves the system. That is a Q is equal to 0. Now next point I am going to discuss, that is the thermodynamic equilibrium. Today class last point I am going to discuss, thermodynamic equilibrium. What is thermodynamic equilibrium? Then in a system, thermodynamic equilibrium in a system implies the existence of the following three equilibria simultaneously. Always three equilibrium will be shown by every time. Okay. Thermodynamic equilibria in a system indicates or implies or tells the existence of the three equilibria at a time. At a time, three equilibria. What are that three equilibria? All three equilibria simultaneously it exists. Okay. Then what are that equilibria? Then first is thermal equilibrium. Second is mechanical equilibrium. Third is chemical equilibrium. Correct? Then you might have heard the name of chemical equilibrium, but other two you might be not knowing. Then three equilibrium always exist. First is thermal equilibrium, second is mechanical equilibrium, third is chemical equilibrium. Okay. Then what is actually thermal equilibrium? Very simple way you can understand. In thermal equilibrium, no flow of heat from one part to the another. When there is no flow of heat from one part to the another, that is a T is equal to constant. That time you can tell it is system is in thermal equilibrium. Thermal means heat. Thermal is equilibrium means every time same things. In general way you can understand. Then here always heat will be the same. T is equal to constant. Temperature is constant. Means no flow of heat from one part to the another. Then that condition or that equilibrium is called thermal equilibrium. Second is mechanical equilibrium. Means no flow of matter. Along with heat, matter also flow. From one point, from one side, matter can go to the other side. That is actually mechanical, meaning of mechanical. Change of matter. Then no flow of matter from one part to the another. Means P is equal to constant. Pressure is constant here. Generally anything will move due to the pressure difference. Anything will move due to the pressure difference. If pressure is constant, then there will be no movement, and that equilibrium will be called mechanical equilibrium. Then in mechanical equilibrium, no flow of matter from one part to the another. And third, chemical equilibrium. Then here what will happen? Chemical equilibrium means here no change in composition. No change in composition of any part of the system with time. After 1 minute, 2 minutes, 3 minutes, what you are thinking? That there is no change in composition with time. What was in the beginning? Always other second also, third second, fourth, every time composition will be the same. Composition will not change. No change in composition of any part of the system with time. Then you have seen any reaction when it is in equilibrium, concentration will be the same. Same concentration, no change in concentration. Then this is called chemical equilibrium. Means in chemical equilibrium, no change in composition of any part of the system with time. And today I am stopping only here. Next class again I will continue. Thank you.